Hello students, I am Dr. Sanjeev Ponia. In last lecture of computer graphics, we were discussing about clipping. But because of network problem, the lecture cannot be complete. So let's start clipping from the starting one. As we discussed, clipping is the process of deciding that the part of an object is visible or not, or we can say that which part of an object we have to show or which one we have to hide. In this, there are different type of clippings, but we have to study only point clipping and line clipping. In last lecture, we complete the point clipping. So here we are starting from the line clipping, and lines can be in different ways. As I told you that suppose this is a window, then in the window, first case is this, that the line is completely visible as you can see on the screen. So both the endpoints are inside the window in this case. So there is no need to click the line. In second case, when one point of line is inside the window and second point is outside the window, in that case we may have to clip or we may not have to clip. It's depend that where is second point. So in case of third one, when both the points are outside, then we also have to decide by the equation that which part we have to clip or which one we do not have to. Over here, we have to study Cohen-Sutherland line clipping algo. As I told you that to compile the Cohen-Sutherland line clipping algo, we have to divide the word plane, that is word coordinate, in 9 different parts. First one is window, first one is window, and other 8 regions are, or other 8 parts are, this is one that is above the window, second is below the window, third one is in the left of the window, this is second, this is third in the left of the window, fourth is in the right side of the window, fifth is in the right above or right top, sixth one is the left top, seventh one is the bottom left, and eighth is in the bottom right. So these are different 8 regions, and one region is window. So there are different 9 regions in which we can divide the complete whole window. So to represent the different regions, we have to use a 4-bit code. A 4-bit code that represent that this is above the window, below the window, in the right of the window, or in the left with the window. So by using these 4 bits, we can find the position of a region. Suppose in first bit we are storing that this is above the window. In second we are storing for the below position. In third one we are storing the right position, whereas in fourth we are going to store the left position. Take the example of this. This is above the window. Whatever the code we have to give, those are with respect to window only. So as first bit represents above, and this is the above the then window, so first bit is 1. This is not below, this is not in the right, and this is not in the left, so all other bits are 0 0 0. Over here you can see that this is not above, this is not above, this is below, this is below, this is not in the right, and this is in the left. So by this way we can assign the different region codes to represent world space. It is not necessary that we have to follow this sequence. The sequence can be changed. It can be left, right, above, below. But whatever the sequence we are following in one region, the same sequence we have to follow in other regions also. This is the thing we have to keep in our mind. So this I told you that how we can assign the labels to different points of a line. Over here you can see that as this is above, this is above, so I wrote only 1 and rest are 0. Over here you can see that this is not above, this is not below, this is in the right, so this is 1 and this is also 0. So this is the way we can assign the endpoint region code. So when we have to solve the clipping, in that case, first of all, we have to assign the label codes to both the ends of a line. To perform Cohen-Sutherland line clipping algorithm, there are 2 phases, or we can say that we can complete Cohen-Sutherland line clipping in 2 phases, where phase 1 is the identification phase, means in this phase we have to identify about the visibility, invisibility, or clipping candidate, whereas in phase 2 we have to perform the operation of the clipping, or this is operation phase. So first we will try to understand about the phase 1, that is identification phase. So let's start about the phase 1. So in the phase 1, as I told you, there are 3 different things that can be happen, or 3 possibilities. First is visibility, second one is invisibility, and third one is clipping candidate. So first we are considering about the visibility, that is the lines, those are visible to us. You can see a line over here that is P5, P6, P5, P6. As we discussed the region codes of all the regions, then the region code of Windows are 0000, and the region code for P6 also is 000. So a line is visible the when the region code of both the endpoints are 000. So there is no need to click the line, or we can say the line is completely visible. So this is in the case of visible lines. Now in second case, that is invisible. So over here you can say that there are two lines. First one is P11 and P12, and second one is P13 and P14. If we are going to find the region code of line P11 and P12, then region code of one end, that is P11 of this line, is 1010, as this is above the window and in the right of the window. And when we are going to find the region code for P12, this is 0010. And when we are going to perform the AND operation between these two, between the region code of P11 and P12, then this is the value of this is 0100. So the value is non-zero. It means this is completely outside. From line P13 to P14 also we can justify this, that the region code of P3 is 0101. 0101, and the region code of P14 is 0110. So when we are performing a AND operation between these two region codes, then the result of AND is 0010, means this is a non-zero value. Means when the AND operation of two endpoints is non-zero, then in that case that is completely invisible. In third case, as you can see from here, that this is about the clipping candidate. So in case of clipping candidate, these are two lines, P9 and P10, and second one is P7 and P8. We will try to find out about these two lines. Then the region code of P9. The region code of P9 is 0000, as it lies in the window portion. And region code of P10 is 0100, as it belongs below the window region, and we are performing the AND operation between these two. So 0 and 0 give us 0, second 0, and this 0 also give us 0, and third is also 0, fourth is also 0. So by performing a AND operation between these 2, we are getting 0. So in clipping candidate, when we are performing a AND operation between the region points and we get a 0 over here, in that case, that is clipping candidate. Clipping candidate means we have to clip this line. Now we will try to understand this on second line, that is P7 and P8 also, and we will justify that it is right or not. The region coordinates of P7 is 0001 as you can see from here, and region code of P8 is 0010. So P7 region code is 0001, whereas region code of P8 is 0010. And when we are performing a AND operation between these two, so we will get a 0. So when we get a 0 by performing a AND operation, in that case, we have to perform the clipping. So in third case, we have to start the phase 3, that is operation phase. And in operation phase, we have to click the line. So now we will study that what is the different way or what is the procedure by which we can clip the line. So first we have to compare the corresponding coordinate of the region with the endpoint regions of the line. As in this case, the region coordinates are 0, 1, 0, 0. Whereas the second coordinate is 0, 0, 0, 0. So from here, we can check that the second bit is 1 and second bit represents below, as we discussed earlier that 4 bits is the representation where first bit represents above, second bit represent below, third bit represent right, fourth bit represent left. In this second bit is 1, it means it is below the window. So when it is below the window, it means it cut the window at lower edge. Means we have to find out the value of Wy, and that will be between Wy min and Wy max. So over here you can see that line P9 and P10. This is P9 and P10. Do not cross the left and the right boundaries because left and right values are 0. So we have to calculate the P10 dash. And when we have 2 points of a line, then we can find out the third point of the line by using the equation of a line, that is y equals to mx plus c. As in this case, this line cross the x-axis over here. It means we know the value of y, and y value is Wy min. When we know one value, then it's easy for us to find the second value, that is second coordinate of the line, and it can be find out by the equation x equals to x1 plus y boundary value of y boundary minus y1 divided by m. And this equation came from the general equation of a line, that is y equals to mx plus c. In second case, when this line cut the window on the left or on the right edge, then in that case we have to find out the value of y. Means we have the value of x, and the value of x will be wx min or wx max. So by finding the value of slope, that is m, we can easily find the intersection point of line with window edge. So this is one example we will see over here. So example number 1, in this example we can see that the coordinates of the line is the coordinates of the line is 0 0 0 0. When we are going to find the coordinates based on region, so region coordinates of the line are 0 0 0. This is the region coordinate, not the point coordinate. The point coordinate will be in x and y form. Means there will be the value of x and y as we represent in a coordinate system. Here we are considering the region bits. So in the on the other end of the line, we can say that this is 0 1 0 0, and it's easy to find out by comparing the bit corresponding bit, that it is below, left, right, or above the window. So from here the second bit is 1. It means it is below the window. It represents that it is intercrossing at x-axis. In second example, you can see over here that when we have the second line, that is P7 and P8, where the region coordinates of P7 is 0 0 0 1, and last bit, that is fourth bit, is 1, and this fourth bit represents left. It means it is left from the window. And when we are considering the second point of this line, then the region value of that is 0 0 1 0. And by seeing the region value, that is 0 0 1 0, the third bit, that is right bit, is high. The value of right bit is 1. It means that this point is in the right from the window. So when we have to find out the intersection point of P7 with window, then we can consider it P7 dash, P7 dash. And as I told you in the last slide, that we can find out the intersection point by using the line equations where we know the value of this point, that is P7, and the value of P7 dash where we know one value, that is Wx min of P7 dash. So it is easy to find out the value of slope, that is m, as we have 2 points, that is P7 and P8. These two are the original points. By these 2 points we can find out the value of m, and again we can put this value in the equation. So in this case we can completely clip the line P7 and P7 dash. You will see in the same example, when this line is in the left hand of the window also, this line is also in the right hand side of the window also, means it intercrosses at left as well as right edge of the window. Just the way we calculate the left point, that is P7 dash, by using the slope of the line, we can find out the value of P8 dash also, as this one represent that this is in the right of the window or with respect to window, then it's easy for us to find the value of P8 dash, and we can say that P8 and P8 dash is completely outside now, so we can click the line, or the line that is P7 dash and P8 dash is visible. In next class, we will discuss about the hidden surface removal algorithm, that is depth buff depth buffer algorithm. Thank you.